In this video, we will be doing a proof involving a circle, and a couple things before we begin. A circle has radii. Generally, with a circle proof, you'll be drawing radii. Not always, but generally, and we will be here. Next, you'll notice that there is one given, and we have this whole proof here. It will become apparent. Just work through it, and you will get it. So now, given, angle ACP is a right angle, prove C is the midpoint of AB. We're going to do the proof down here. We're going to write it out on the diagram. Angle ACP is a right angle given. So angle ACP is a right angle. Let's put that on the diagram there. Angle BCP is a right angle. The supplement of a right angle is a right angle. So supplement of a right angle is a right angle. Draw AP and BP. Reason, 2 points determine a line. So we are going to be drawing auxiliary lines, AP and then BP. So 2 points determine a line. You can draw a segment between any 2 points. Next, AP is congruent to BP. All radii of a circle are congruent. So here we go, AP and BP. All radii of a circle are congruent. PC is congruent to PC, reflexive property. We're going to have two triangles here, and PC is in both. You can see the triangle here and the triangle there. Next, triangle PCA is congruent to triangle PCB, HL postulate. We have two triangles here, and we have the hypotenuse, and we have a leg here, which is in each one. Next, AC is congruent to BC, CPCTC. Corresponding parts of congruent triangles are congruent. So AC here is congruent to BC here. Next, C is the midpoint of AB. Definition of midpoint. We've got C right there. AC is broken up by C into two congruent segments. So C is the midpoint of AB, definition of midpoint. And as we often do here, we're going to take out the written proof here and just do it on the diagram so you can see the thought process again. Angle ACP is a right angle, therefore angle BCP is also a right angle. Next, we are going to draw segment AP and segment BP. 2 points determine a line, and they also happen to be radii of a circle. Therefore, AP and BP are congruent. Next, PC is congruent to itself, reflexive property. And remember, when you're doing proofs in geometry, not always, but in general, you're looking for congruent triangles. So now here we have triangle ACP and triangle BCP are congruent, HL postulate. Therefore, these two triangles are congruent. Therefore, AC is congruent to BC, CPCTC. And then from the definition of midpoint, if a point divides a segment into two congruent segments, it is the midpoint. As always, the best way to do a proof is to write it out, then do it on the diagram 3 more times.